So I'm here to talk initially about API design at Eventbrite. So a quick sort of poll, first of all. Who of you here have written APIs in the past? Just simple ones, complex ones? Okay, that's at least half the room. Who of you have used APIs in the past? That's, yeah, even more people. So coming into Eventbrite, one of the very first things I was given was this problem, the idea that Eventbrite has an API, but actually it has two APIs. In the best kind of development effort, API v1 is at least 6 years. I went back in Git. I got 6 years back into Git, and it says imported from subversions. So it's at least 6 years old. And API v2, which was, of course, called Next Generation API, very bad name to give anything. It's like calling a design final. It's never a good thing to call that. It was started, never finished, and sort of is now heavily tied into our mobile apps and powers them very well, but it's got a lot of design decisions that tie it heavily to mobile and isn't really good for general consumption. And so the overall issue here was to try and get an API that wasn't sort of as stuck in the past as API v1 was, that wasn't tied down and sort of in this sort of small corner as API v2 was. So some of the problems with API v1, which is our current public API that we had previously, it was outdated. The code was all pre-Django, because we moved to Django 3 or 4 years ago. There was no provision for new features. There was a lot of sort of interface and design ideas around the URLs and the methods that were just locked down to how Eventbrite worked 5 or 6 years ago. Things like the way payment methods work, the way repeating events worked, all that kind of stuff. There's also some bad patterns in there. It was on the same domain as the main site, which is easily fixable, but already a bad sign. It had methods accessed just as, so it's eventbrite.com/XML, question mark method, this is not perfect. And also, it has the wonderful thing of both the XML and JSON return formats it gives you are actually transformers of each other, which is a great idea in theory until it turns out in practice that one of them isn't really correct. So there's both misformed XML and also poorly written JSON in that output of that API. So that's always a fun one to deal with. So the task is take all this stuff and take what Eventbrite is now. Like, we're adding new features at a rapid pace. We've got all these wonderful new things. Reserved seating and stuff has come out as well. And try and work that into an API for the modern era, and one that isn't going to sort of make developers run screaming when they see it. So the first key thing for us is that we have SOA internally. For those who aren't familiar, the acronym is Service-Oriented Architecture. It sounds very enterprisey. It's not. What we're doing is splitting apart the code base from this one giant monolithic blob into much smaller services that are much more manageable by small teams. For example, we're pulling out events into their own event service, the idea of the order flow and ticketing into its own service, of reserved seating as its own service, that kind of thing, and trying to organize it so you've got smaller code bases that can be released independently, tested independently. But the nice thing here is that mapping of bringing out services and ideas, and you expose them as sort of methods, as endpoints, and that matches the idea of an API very closely. And so one of the ideas here was to try and minimize our duplication and make it so that our SOA work, just split the stuff out internally, which is still ongoing, and our API work was sort of closely intertwined and wasn't too dissimilar. So in a way, what we do here, this doesn't fit well on the screen, but we have sort of these services internally. They talk between each other. That's all perfectly fine. And then we have sort of internal SOA clients. So like our website be talking to it or something like that. And what we wanted to do is to have that same kind of interface mapped to API clients. And so the idea is an API client just talks through this sort of translating layer that is API v3. It does things like whitelisting, like security, and a few other things. But in its essence, it's just pushing through those API calls into some part of our underlying infrastructure. And that means that as we maintain and upgrade these internal services, that also affects our API. That's a minimal sort of extra work to keep it updated. Obviously, the APIs have to be frozen, so that mapping layer will grow over time, some freezing, some remapping to try and keep that external interface consistent. But it saved us a lot of time already just developing the new stuff. Coming into that whole idea of freezing, APIs must be future-proof. A very big part of my job here has been thinking, okay, this is fine now. In 1 year, in 2 years, what are we doing? What's the planned roadmap? What could go in here? And one of the big parts is designing all your responses and designing the way you query things to have easily good breakpoints, things you can add new things in, where you can change fields, where you can sort of easily add things in a nice backwards compatible way without necessarily breaking stuff. It's not always the case. You obviously have to break stuff eventually, but it's a big part of designing the APIs, trying to make sure that it's not going to immediately break 6 months down the line and you have to change the documentation and our developers who are using it come to us screaming in anger and ugh. Maintainability is important too. I personally believe that one of the most difficult things about writing code, especially in a big company like this, is you need to make it easier to extend your code and to throw it away and start again. Now, admittedly, I did this with the old API code. I am guilty of this partially, but I think a big part of API code and the new stuff we're doing is making it so that if you are developing one of our many teams we have, like they're all product focused, say I'm working on the organized acquisition team, they're responsible for getting new events in, that kind of stuff. I want the ability for them to go in, easily find the right piece of the code to add stuff to, and have it be 10, 20 minutes out of their day. If it's a massive task for them to add a new API endpoint, they're just not going to get added. Over time, we'll lose them, they'll come out of sync. So we need to make sure that there's a very easy, low barrier of entry to this kind of stuff. So with all that in mind, what did we do? The key thing is we started off with Django REST Framework. Django REST Framework is an excellent piece of software written by one of my friends, Tom Christie. And essentially, so there's also a piece called Django Piston, for example. Django Piston is sort of model-oriented. REST Framework is much more traditional Django in a sense. It's based around views, around middleware, around pluggable components like authenticators and sort of rate-limiting stuff. And it's a very good base to build from. And we don't even use REST Framework sort of in its native state. We've heavily modified parts of it, but the beauty of it is that you can easily take away different parts. Like authentication is entirely different. Our serializers aren't even there anymore, but the rest of it works perfectly in isolation, and that's also what's good about it. Behind the REST framework, we have that sort of custom coupling to our SOA library, I said. So as I said, the API is kind of this mapping onto our service-oriented architecture. And so what's in the middle there is sort of a nice, simplified way of saying, OK, this URL maps onto this endpoint, or this URL calls these two endpoints, combines the result. And so when someone comes along and they're writing a new feature in main Eventbrite for the main website, they're writing some services for those, and they can come along and easily go, OK, here's my SOA endpoints, here's a URL for it, and map it straight through. And that's meant to be sort of as low cost and as frictionless as possible. Piecemeal refactors. Now, the sort of interesting part of all this is that the API is one of the first parts of this service-oriented future. And so many parts of it have to sort of take existing code and tease it out in sort of this sort of slightly service-oriented way, enough so we can call it in an individual fashion. And so part of this has been taking parts of Eventbrite, which is, as you can imagine, is a very complex code base full of wonderful, 7-year-old dead ends and really special cases, trying to work out how to contain those and put them into a module by themselves. And the key there is to do it small and test heavily, as Nathan said, and make sure you're getting that covered. And it's been slow progress, but we've almost got to the point we've got all of the old API code in a new version, fully tested, fully extracted, and it's wonderful. And finally, the key thing from a business point of view is that we have this old API. It's still public now, and we can't deprecate it until it's fully replaced by a new one. And so in terms of aiming for an initial release, we need to aim for a full replacement of that old API so we can deprecate it, start that sort of 6-month, 9-month, 1-year deprecation cycle, give all of our clients time to upgrade and notify them properly, and then we can finally drop it at some point in the future. Obviously, if an endpoint stops getting hits on API-v1, we can do it early, but it's a much more difficult and involved process, and we have some big customers we need to take care of, so that can be tricky. So with all that in mind, what are the design principles behind this? So this is sort of my personal bugbear. It's only JSON. Now, this is kind of a tricky one. Some of our clients love XML, but when you actually ask them, that's more because they're used to using it. And the beauty of having just JSON is that you've only got one return format to take care of. You can design that and make sure it's properly consistent across all platforms, and it works well. If we do need XML in the future, I'm sure we could ship a translator module in the future, just ship it in there. But every modern language has access to JSON. Old languages, there's a JSON module for Fortran. I mean, everything uses it now. It's a very simple on-the-wire format. My only bugbear is there's no datetime format in JSON. That really annoys me, but we've defined a few things like when we return currencies and dates, we have well-defined formats and say okay, currencies come back as a dict of currency code value and so on. It's REST-ish. Now, I'm not a REST purist. Some of you may be. You may hate me for the next slide. We don't have put. We deliberately don't have put because I don't really like put. But anyway, the argument in REST is should you use put for updates, should you use post for updates, and things about URL mutation stuff. At the end of the day, you can kind of map post and put to the same task on any given URL anyway. I'm sure we'll support put as a sort of synonym for post as well. But it's, so designing a sensible, nested infrastructure of URLs is my key thing here. Like the idea that, slash events is a list of public events, and when you post and make a new event, then ID on the end, adds event details, you can upload the event, then slash orders gets you the orders for that event, and then you can have an order on that. And so there's a nice sort of hierarchy there of how those flow and how you can sort of almost navigate down the tree of the way this works. And also, there are some things like you can publish and cancel and unpublish events, which are basically verbs in the event. And perhaps in an ideal world, they'd be HTTP verbs like publish. But given proxies stripping out a lot of proxies strip out verbs they don't know in HTTP. I've had massive issues in the past with using custom verbs, so we just went with custom URLs here with post on the end instead. And then, similarly, we also have a nice thing here where if you put, with a username, if you put me in that URL, that just aliases to your current user ID. So you can hack around and go /user/me, and you can play around the API very easily. It's meant to be sort of heavily explorable, easy to just sort of play around with, get your data out of it very quickly. Another very important thing is sort of part of the future-proofingness is every response is a dict or an object, depending how you come from. Nowhere do we return just JSON of list, objects, end list. The idea here is that there's room for pagination, most importantly, and there's also room for future expansion if we return more than one list, all that kind of stuff. Similarly, every object we return, we never return an empty, like errors are always a dict of error something. There's always room to add more keys in there. And nearly all code that reads JSON return formats won't error if there's extra keys. Extra keys are usually fine. And so our approach to this is extra keys are fine, we can leave space for them in the future, just don't drop stuff and make sure we have that place to add them. Finally, as part of that sort of standardization that I love having, pagination everywhere. I've been bugging Simon about this in particular. Everywhere we return a list is paginated, just as pure sort of, it might seem small now, like, we only have 10 languages now, you only have so many categories now, but if we get 100 or 1,000 in future, we can't change it if it's not paginated. And so having that sort of consistency there and the future planning means that as you scale, which even at Eventbrite size, we still have room to grow, and a lot of it, there's no surprises in the future. So this all rolls into this wonderful idea of an API that is sort of intelligent and also introspectable. All the code is written in a way where we have code that can go into those methods, can read what they're doing, what they're calling, the fields you can pass them, the formats of things you can pass them. And that sort of turns into this automatic API explorer. So sort of, if you hit any of our API endpoints in a web browser, we do content negotiation and say, oh, wait, you can see HTML, and this pops up. And so as well as returning you this response here, which is the actual response from the API, you have the status codes pulled out for you, all the headers pulled out for you. We have what we've resolved your authentication to be, and resolved through, like, say, you pass this token, we thought that this app ID, we thought that's this user, so like all that debugging is solved for you. And then also, on the far side over there, you have these forms where you can just say, okay, we have get, takes no parameters, that's excellent. We have post, takes one thing called name is required, and all this stuff is automatically pulled in. And we're also going to have our API documentation, which is powered by Sphinx, pull in this too, and sort of automatically create our documentation, just save us a lot of time in working out all these endpoints. And this feeds back into the idea of maintainability and low barriers. For our new developers writing new features, we want the ability to have an endpoint page with all the fields, with the documentation as easy as possible, and that all feeds into this. There's just one more example of these forms. So this is our pagination, pulls out here. We get a nice little header here saying pagination, have all the side fields over here, so like this is a much more complex thing. This is making a new contact on one of our contact lists. And you can see it's sort of like, it's a much more, compared to the old page, which just give you this, unsyntax highlighted as well. And this links through URLs and stuff. And this is all, Django REST framework ships with the basic version of this. I took their template, I customized it a bit. It's customized quite a lot, actually. But the same idea is there. And so I'm a heavy believer in the idea of APIs that are explorable, that are easily accessible, that you can sort of just go to them and play around with them, either via one of these explorers that are on page, or via a separate explorer. So like Twitter having a separate explorer, you just pick one down the list, it works. Those are both fine, but I really like that. And the key thing is there's always more to do. An API is never finished. An API is only finished when your product is finished, and that's probably never. And so you've always got a plan for what's the next feature, what's the next change, what are we removing this week, this month, this year. Like, for example, we're redoing our categories right now. That means we're going from one category, multiple categories per event, to one category and one format and one subcategory. Like, that change in itself is complex. So you've always got to be on the ball and be aware that even if you're writing the code today, you're not the one writing the code in a year or 2 years' time. Like, think of your future developers and your future co-workers and make sure that their job isn't really hard. And with that, please try our API today. It's available there, it's the documentation, and part of it's up already. And thank you very much.